Law of gaseous volume. So what does it mean? It means to say how these gas molecules are going to be arranged, how it going to be occupy the places. Okay, so that and all will be the made as a law. So that is called gaseous volume law. I think you might have know the differences of arrangement of molecules when we are comparing solid, liquid, and gases. So solids are compactly packed, liquid are loosely arranged, and your gaseous molecules are freely moving. So which having a more intermolecular force of attraction. Please note down the point. Intermolecular force of attraction. So today's assignment, what do you mean by intermolecular force of attraction? So if it is there, so that arrangement of molecules is closed. If it is less, that is your loosely packed molecules. So today's assignment, what do you mean by intermolecular force of attraction? That is your today's assignment. Okay. Next. This law is proposed by Lussac. Gay Lussac. Okay. Gay Lussac. In the year of 1808. In the year of 1808. So what he explained means, your gaseous molecule will take the volume, okay? Your gaseous molecule will take the volume wherever you are placed in the combined state. What he did, he just observed the gas combination or gaseous combination with a chemical reaction. So what he did, he just with the gaseous molecule, he'll react with some chemical. Okay, he react with some chemical that react with that. Okay, the gaseous molecule will react with this chemical. It will give you the ratio of. So what do you get? The product. So the product is a ratio of volume of provided all gaseous or in same or at same temperature and pressure. So I'll explain it now. What does it means I'll state the law also. Please try to understand what he's trying to explain. So when a gas molecule is combined with any other things, okay, it's combined with any other things, the volume is also going to be the duplicate of it. It means to say, for example, by writing an example, I can give. So this is O oxygen chamber. So it's occupying. This box seems to be A. Okay, so we are filling oxygen. And in one more chamber, we are taking hydrogen, and this box seems to be B. So when we are combining these two, okay, when we are combining these two things, the volume of gaseous occupy, it seems to be double of it with the same pressure and temperature ಅಂತ ಹೇಳ್ತಾರೆ. Pressure and temperature. Okay, ಅರ್ಥ ಆಗ್ತಾ ಇದೆ ಅಲ್ವಾ? So how much the gas will occupy the space or volume that is combining with any of the chemical, the volume is provided for the gas, it seems to be double of it with the same temperature and pressure. Okay, got it? So now write the statement for the law. Screen is visible. Harsha Kumar, screen is visible. So now you just see that how he explained the law. When an gaseous combined, write down fast, combined or produced in a chemical reaction, they do so in a simple ratio by volume provided all gaseous are at same temperature and pressure. This is a statement. So this law of gaseous volume is composed by, or the law stated by Guy Lussac in the year of 1808. What he just say, when a gaseous molecule is combined with any other molecule or is undergo chemical reaction, the ratio is between the sum of these will impact on the volume that at the same temperature and pressure. So if it seems to be, you can guess it out, ma'am, why is using the word called same temperature and pressure. Okay, same temperature and pressure. Yes, the volume seems to be double. Okay, the volume seems to be double. If A is combined with B, then of course the volume should be double. But what he said, he's saying that at the same temperature and pressure. What does it mean? It means to say the pressure and temperature which should not be applicable on it. So what he trying to say means, suppose this is the chamber we applied, and if we put a piston and reduce the pressure of it, the volume may decrease. It may decrease than the before. So that's why this rule is not applicable when you're pressurizing it. Then temperature, if you keep on rising the temperature of the gas molecule, the molecular force of attraction between the molecule will be higher, and it tends to move faster. So that's why the volume occupies more when you are comparing the basic. Are you getting my point? Screen kanistaa ilva? The screen is visible. For everybody, screen is not visible. The both of it. Is it right? So if the volumes seems to be both of the volumes, then if it seems to be same size, then we can say it's a double of it. Can we say like that? So what I'm trying to explain means this, right? So now in law constant, what they were given to explain means, you are combining the oxygen molecule. You need to make a water molecule form it. So what you are taking H plus O, because water molecular formula is H2O, right? So that's why you need 2 container of H plus. These 2 container of H plus get neutralized with 1 container of oxygen. Is it right? Is it right? So in that example, in that given example in your textbook, what they were explaining means, when these 3 molecules are combining, and it should be triple of the size of it, but it will give you the double size. Why? Because this all three will form one molecule, not an two molecule. So suppose hydrogen with one O, you can say the double of the size. Okay, you can say double of the size. Yes, ma'am, that's fine, no problem. But I'll send, no need to worry. So if it seems to be H2O, then the hydrogen space should be of retaining the same thing. It doesn't make double sense of it. That's why he is explaining with water molecule. But when you are taking with H2SO4, 3, the volume should be triple. So what he trying to explain, the hydrogen is combined with hydrogen. So then it's from H2. Then the size will reduce because same molecules are going to be combined. That's why in your textbook, page number 12, I think so, what they were giving with the 3 volume of the gases size, they combine to make it double because it will form one water molecule. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಒಂದು ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ ಅದು ಫಾರ್ಮ್ ಮಾಡ್ತಾ ಇದೆ ಅದಕ್ಕೋಸ್ಕರ. So the law explanation, what he tried to explain means when the gas molecule, okay, this gas molecules is combined with any other chemical reaction. So he's saying, instead of saying one more gas molecule, he's saying whatever the chemical. Okay, whatever the chemical. So what he did, the sum of these two, okay, the sum of this molecule are going to be the ratio of, ratio means 1 by, like this, right, 1:2, like the ratio. So the ratio should be volume provided. How much volume? In that volume it will be retaining the same kind of thing. It means to say the ratio are going to be constant with their volume. The ratio are going to be constant with their volume with the same temperature and pressure. With the same temperature and pressure. Are you getting my point? ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ಸಿಂಪಲ್ ಆಗಿ ಹೇಳ್ಬೇಕಂತ ಹೇಳಿದ್ರೆ, when the gaseous molecules are combined, the volume is and small ratio, the volume is and small ratio with the same temperature and pressure. So if we change the temperature or if we change the pressure, what happens? If you are changing your pressure, then the volume reduces. Okay, just think like this is one container, so it is filled with oxygen. So if you are pressing and the intermolecular force of oxygen will become less, so the volume occupied by the gas also become less. So when you are pressurizing it, volume become low. Okay, now for temperature, if you are raising the temperature, the gas molecule will gain the temperature and it will move wherever it want. So it will lose the intermolecular force of attraction and the volume become more. ಅರ್ಥ ಆಗ್ತಿದೆಯಪ್ಪ? able to get this? ತುಂಬಾ ತಲೆ ಕೆಡಿಸ್ಕೊಳ್ಳೋ ನೆಸಿಟಿ ಇಲ್ಲ. when the gas molecules are combined, the size is going to be increased. ಅಷ್ಟೇ, simple statement. Is it okay? Clear? Speak out. Rajesh, Gokul, Ghana. Next, Avogadro law. Avogadro number. Please focus on this because this is very important. Do you know what do you mean by Avogadro number? First, we are going to read Avogadro law. What do you mean by Avogadro number? What do you mean by Avogadro? Do you know what is the value of it? Okay. Avogadro law is proposed by an Avogadro in the year of 1811. So what he did, he trying to explain the number of atoms present in one drop of molecule. I have a complete derivation upon this, but I think you don't want that. You want only the value of Avogadro. But here he is proposing the law, Avogadro law. So what he explained, equal volume of gases, equal volume of gases at same temperature, at same temperature and pressure and pressure should contain, copy down fast, should contain equal number of molecules. What he said, so I'll just convey the message of Avogadro in the simple words. Yes, 6.023 into 10 raised to minus 23. That is Avogadro number. So what he trying to do means, sorry, first ಏನ್ ಮಾಡ್ತಾನೆ ಅಂತ ಹೇಳಿದ್ರೆ he's going to take up the different gaseous molecule. For example, oxygen, hydrogen, nitrogen, sulfur. So he's going to take different gaseous molecule, okay, different gaseous molecule. And what he did, so he's going to take all the gases in the same volume. Same volume means whether it may be 0.1 liter, like that. Okay, so same volume he's going to take all the gases. So what he explained means, if the gas volume is same, even though the gases are different, for the different gaseous molecule the volume remains same, and the number of moles over there, number of moles are equal with same temperature and pressure. So ಏನು ಹೇಳ್ತಿದ್ದಾರೆ ಇವರು ಅಂತ ಹೇಳಿದ್ರೆ, just listen now, the gaseous molecules are seems to be with the same volume. If the gaseous molecules are seems to be in the same volume, the volume, it seems to be same, then the number of moles also should be same ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. The number of moles should also be same. If volume remains the same, so how much it can having the ability of reticule, that is specific for all. That is specific for all. So for example, you in your hand you can hold one wrist of things. Okay, one wrist of things. So whatever you have, you can hold one wrist of sugar, you can hold one wrist of dal, you can hold one wrist of sweet. The one wrist is remaining always same. The content may be different. Okay, the content may be different. And number of particles. For example, sugar crystal you are holding, okay, you are holding, suppose it seems to be 1000, okay, 1000. Then the dal size, if it is seems to be almost nearer by it, the volume or seems to be same, the volume or seems to be same, the number of particles of sugar should be equal with your number of particles of dal. Is it cleared? Okay, so he's directly explaining that if the volume is remaining the same, if the volumes are same, then the number of particles should be equal without any changing in the temperature and pressure. So for all the gaseous, you need to state this with the same temperature and pressure, because if temperature and pressure is changing, then of course the volume of the gaseous will changes. So only simple statement Avogadro gave. What he gave, If the volumes of gases remain same, the number of particles should be same with the temperature and pressure. Okay. So how we gave that number, how we got to know that it's of 6.023 into 10 raised to minus 23, that and all we'll take up in tomorrow's class. So you have that small note kind of thing. So I'll explain it. So this concept, what we did, Avogadro number with your gas volume law. Is it clear? Is it clear? Any doubts? Any doubt you can ask me. Otherwise, we are going to end up our session. I'll send the pics and record it too. Okay then, thank you so much. Have a good day. Bye-bye.